Welcome, class. This is the periodic table of elements. Please fill out your Cornell notes using this video. This is an interesting site called periodictable.com. It has very interactive videos and lenticulars over all the elements of the periodic table. Let's get started. Dmitri Mendeleev was the first person who organized the periodic table. As you can see, in his early sketches, there are places where he has left blank where he knew elements should be, but they have not yet been discovered. The elements' properties he did know, he organized in groups and somewhat into periods. Dmitri Mendeleev was a Russian scientist, and he started this around the 1860s. Okay, let's look at the periodic table close up. First, we have neon. Neon has an atomic number of 10. Neon also has an atomic mass of 20.1797. We can round that atomic mass and find the mass number. So the rounded atomic mass would be 20. Since after the decimal, the number 1 is not 5 or more. It stays at 20. Now, let's look at the number of protons. To find the number of protons, we're going to look at the atomic number. The atomic number means the number of protons. The atomic number also, in our case, means the number of electrons, since we are dealing only with neutral atoms in the 7th grade. To locate the number of neutrons, we have to do a simple math problem. The number of neutrons is found by subtracting the mass number 20 and the atomic number 10, which will give us 10. So the number of neutrons equals 10. It will not always work out 10, 10, 10. So don't give yourself a guess before you do the math. Here's the periodic table. To find things on the periodic table, we need to know a few words. The first word is period. Period means the row as you go across the periodic table. Periods for a periodic table are 1, 2, 3, 4, 5, 6, and 7. The next item I want to look at are groups. Groups are the columns. Groups or families have similar properties. So every element in group 1 have properties that are alike. Group 2 has properties that are alike, as well as 3, 4, 5, 6, 7, and 8. I just named all of the 8 main groups. The next thing I want to point out are energy levels. How to find the number of energy levels an element has, we need to look at the period it is in. If an element is in period 1, it will have 1 energy level. If the element is in period 2, it will have 2 energy levels. And again, if the element is in period 3, it will have 3 energy levels. And when I talk about energy levels, what I'm talking about is the number of rings around the nucleus. So however many rings are around the nucleus relates to how many periods on the periodic table. The next thing I want to talk about is valence electrons. Valence electrons relate to groups. So elements that are in group 1 will have 1 valence electron. Elements in group 2 will have 2 valence electron, as well as 3, 4, 5, 6, 7, and 8. That brings me to talk about main groups number 1 and number 8. In the main group number 1, you have only 1 valence electron. And if we remember the rule for valence electrons, we fill up energy levels as 2, 8, 8. So, group 1 has only 1 electron in that last energy level. Group 2 has 2, and 3, 4, 5, 6, 7, 8. So group 1 would be what I call an unsatisfied group. Group 1 is very reactive. It is lacking all of the electrons on its outside energy level and only has 1 that it could possibly have. Whereas on the opposite end of the table, group 8 is what's called satisfied. They have all 8 electrons in their last energy level. They are very stable elements, whereas the elements in group 1 are very reactive. And the last part of our video today is a little review with vocabulary. In your Cornell notes, make sure you include each of these vocabulary words and their definition. If you're unsure of what they mean, watch the video again and I go over every word listed. Another reminder is for our energy levels. In the first energy level, we only have 2 electrons. In the second energy level, fills up to 8 electrons. And in the final and third energy level that we learned in 7th grade, we also have 8 electrons. And I want to leave us with one practice on making atoms, modeling atoms. So here I'm going to do an example for carbon. Carbon on the periodic table is number 6, and its mass number is 12. With that information, I can make a model of how many protons, neutrons, and electrons there are in the element carbon. So we know the top number, or the atomic number, tells us 2 things. It tells us the number of protons and the number of electrons, since we're dealing with only neutral atoms. So the number of protons will be 6, as well as the number of electrons. So I can fill up my first energy level with 2 electrons, and I can't do any more. I have to go to my second energy level. So my second energy level will take my remainder 4 electrons. That leaves me with a total of 6. Matches my proton 6, and it matches my atomic number of 6. Lastly, I need to find the number of neutrons. To find the number of neutrons, I do my simple math equation. I take the mass number, which is the rounded atomic number, and I subtract, the rounded atomic mass, and I subtract the atomic number. So 12 minus 6 leaves us with 6. So the number of neutrons in the nucleus is 6. Let's check our work. 6 plus 6 equals 12 with a mass of 12. So we have successfully modeled the element carbon. Don't forget to do your summary on your Cornell notes as well as your 3 questions. I will be checking them in class on Thursday before you do your study guide. Thanks.